Much. All right. Thank you very much. All right. Yeah, love you inside out. This next song features our drummer Sean Byington on vocals.
What's up, Tony? What's up, Jimmy? Jimmy. All right. got good audio. We like that, man. Like that. It's good. Last night was fun. Kind of went late, but you know, it happens. It was too much fun going on, man. Damn it. Too much fun, baby. Just too much.
Give it up to Sean Byington on vocals there.
Very superstitious, writings on the wall. Very superstitious, let us better fall. 13-month-old baby, broke the looking glass. 7 years of bad luck. Good thing can pass. When you believe in things, you don't understand that you'll suffer. Superstition is real. Very superstitious. Wash your face now. With me at the problem. Do all that you can. Keep me in the bed. Stay going strong. You don't wanna say things. Sad is a song. When you believe in things that you don't understand, then you suffer. Superstition is the way. No, no, no. Very superstitious, nothing more said. Very superstitious, the devil's on his way. The 10-month-old baby, it broke the looking glass. 7 years of bad luck. The things in the past. When you believe in things that you don't understand, then you suffer. Superstition is the way. No, no, no.
What's up, Tracy?
Thank you so much.
All right, thank you,
This
guys.
next one.
You guys are hanging out, man. Far out. And Tony. Jimmy. All right, man. Thank you guys for hanging out, man. Spread the word, man. Spread the word. Have some other people join. You got to check out David Banner's. It's hard. It's weird timing. What? He's in the UK. It's,
Is a debut.
I know that. I always miss Banner's show, man. I did catch last night. He did like an hour. I was laying in bed listening. It was hilarious.
So you wanna drop out your trick bag and ease on into a hip bag, but you ain't just exactly sure what's hip. So you start to let your hair grow, spend big bucks to cop your wardrobe, but somehow you know there's much more to the trip. What is hip? Tell me, if you think you know. What is hip? If it was really hip, that's in the years to show. You win a hip trip, maybe hipper than hip. What is hip?
Raise.
Came from a part of the new breed, been
Only
smoking only
smoking
the
the
best
good
weed, and hanging out with the so-called hippie set. Been seen in all the right places, seen with just the right faces. You should be satisfied, but it ain't quite right. What is hip? Tell me, if you think you know. What is hip? If you was really hip, but that's in the years for sure. With a hip trip, maybe hipper than hip. What is hip? You a guru, and I ever to find you a new you, and maybe even manage to raise your conscious level. While you're striving to find the right road, there's one thing you should know: what hip today might become passé. What is it? Tell me, if you think you know. What is it? If you're really hip, that's in the years to show. You got a hip trip, maybe hipper than hip. What is hip?
So sweet, man. What a band, huh? Dude.
What is it?
Tell me, if you think you know.
What is it?
If you're really hip, that's in the years for sure.
What is it?
Tell me, if you think you know.
What is it?
And if you're really hip, that's in the years for sure.
What is it?
I'd like to know.
What is it?
Is it in the sky up there?
What is it?
Is it in the clothes that you wear?
What is it?
I'd like to know.
What is it?
I'd like to know.
What is it?
What's the hip, y'all?
What is it? What is it?
What's the hip, y'all?
What is it?
Soup. Sue is hip, man. Sue is so hip. Sue is very hip. What's going on, Sue? Far out. Okay, what was this owner? He loaned you his 4Runner, didn't he? Sweet, man. He fixed it. Pro. Nice. Like that. That's good news, man. Excellent, man. That's pro. Bitch the mechanic out. You gotta bitch a freaking ding dong. All right, a couple more tunes, man. We'll get into some physics, man. All right? Cool. Cool.
We're on the horn section right now.
Sweet, man. Thanks for hanging out again, man. I know I've been playing a lot of darts this summer, but what are you going to do, man? They're just really good, man. What are you going to do?
Sometimes I go out by myself and I look across the water and I think of all the things what you're doing, and in my head I paint a picture. Since I've come on home where my body's been a mess, and I miss your tender hair and the way you like to dress. Won't you come on over? Stop making a fool out of me. Why don't you come on over, Valerie? Did you have to go to jail? Put your house on up for sale. Did you get a good lawyer? Hope you didn't catch a tan. I hope you'll find the right man who'll fix it for you.
Fix it for you.
And now you're shopping anywhere. Change the color of your hair. Now you're busy. Did you have to pay that fine? You were dodging all the time like Goose and Daisy. Since I've come on home where my body's been a mess, and I miss your tender hair and the way you like to dress. Won't you come on over? Stop making a fool out of me. Why don't you come on over, Valerie? Well, sometimes I go out by myself and I look across the water
It's flat and level.
and I think of all the things what you're doing, and in my head I paint a picture.
It's flat and level.
Since I've come on home where my body's been a mess, and I miss your ginger hair and the way you like to dress. Won't you come on over? Stop making a fool
Right
out
on,
of
man.
me.
Right on, far out.
Why don't you come on over, Valerie?
Work, man.
Valerie,
So cool, man.
Valerie,
Right on, far out. Good stuff, man. was pro, Jimmy. Pro. So pro, Jimmy.
Why don't you come on over, Valerie?
Come on over, Valerie. Come on. Yeah, it's all good, man. You know, you can go in and bitch and complain and yell and fucking. It always fucking sucks, man, when to do it that way, bro. You just come in and go, look, man, I gotta be straight up with you, man. I need my truck, bro. I'm willing to put in work, Mac. And, you know, I'll come here and work. Can I help the mechanic? You know, I can handle freaking socket wrench. Let's do this, bro. What do we gotta do? We gotta take this off, move that, put this over here, take that off, put the new thing in, put it all back together. Let's go, man. Let's go. Whatever it takes, Lord Racer. What's up, Mac? Fucking Mongo. Mac the Mongo up in the house. 6:30 in the morning. Shit, we gotta rock some music for you, bro. Get you going. Get some tea going. All right, get some tea. Yeah, or smoke a joint. Either way, whatever. I'm gonna smoke a ball and have a beer. Damn it. I wouldn't suggest you start your day like that, but some people do, man. Some people can get away with that, Jeeps. You know what I'm saying? What's up, Jeeps?
One of these nights, one of these crazy nights, you're gonna find one pretty mama that turns on the lights. The full moon is calling, the fever is high, in the liquid wind whispers and moves. You got your demons and you got desires, but I got a few of my own. Ooh, someone to be kind to in between the dark and the light. Ooh, come and let behind you. Swear I'm gonna find you one of these dreams, one of these lost and early dreams now. We're gonna find one, yeah, the one that really screams. I've been searching for the daughter of the devil himself. I've been searching for an angel in white. I've been waiting for a woman who's a little bold, and I can feel her, but she's nowhere inside. Ooh, loneliness will bind you in between the dog and the light. Ooh, come and let behind you
all you guys showed up, man. I'm touched, man. Touched. I was just gonna do some physics. Physics is so boring. You gotta
Thank
do
you
it.
so much,
You gotta know
everyone.
it.
All right, we're gonna invite our friend.
We're gonna invite some friends up, man. There's this big black guy back here, man. He knows the band. He was up there hugging a sax player. He's a big boy, man. There in the corner here, right about there. Yeah, it's
Bobby and
it's
Kev-
pretty. It's not a diverse crowd, man. He's probably the most diverse cat there. You know what I'm saying?
Coming up for this next one. This one is a Wonder song. We have Murph. I have two. We're gonna
Thank you guys for hanging out, man. Appreciate it, man.
When I see you on the street, my whole body gets weak. When you stand, then get the ground. Oh, your love talks to me so loud. Girl, do I do what you do when I do? My love.
What's up, Dax? Wow.
When I hear you're on the phone, your sweet sexy voice turns my head all the
Put the
way
thumbs
on.
down, man.
It's just the mention of your name that seems to drive my head insane. Girl, do I do what you do when I do my love to you, baby? Yes, I got the panic 'cause it's bullets. Yes, I got the panic 'cause chocolate dripping kisses for love for you. Yes, I got the panic 'cause it's bullets. Yes, I got the panic 'cause chocolate dripping kisses for love for you. My life has been waiting for your love. My arms have been waiting for your love too. My heart has been waiting, my soul anticipating your love, 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 love.
That bass player just crushes.
From the time that I awake, I'm imagining a good the love will make. It's to me, if I can do all this, we'll just imagine every time I feel when we hug and kiss. Sugar, do I do what you do when I do my love? Alright. Yes, I got the panic kisses for your lips. Yes, I got the panic like a chocolate dripping kisses for love for you. Yes, I got the panic kisses for your lips. Yes, I got the panic like a chocolate dripping kisses for love for you. My life has been waiting for your love. My arms have been waiting for your love to arrive. My heart has been waiting, my soul anticipating your love, your love, your love, la, 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 la. Oh, I don't care.
Sweet
how long it
bass,
might
man.
take.
Damn.
Yes, I know the woman won't make no babe. And I will not deny myself a chance of being part of this background romance. Girl, do I do what you do when I do my love to you?
So good, man. All right.
Yes, I got the
You guys are-
for you. Yes, I got so many kisses for your lips. Yes, I got so many second chocolate dripping kisses for love for you. Do I do what you do when I give my love to you?
Oh shit! You guys are great, man. Let's do some physics, man. Damn it! I hate to fucking bum you guys out with physics and shit, but what are you gonna do, man? What are you gonna do? You gotta do it, man. I play music. We do physics, music, and then we go back to music. All right. The gravitational constant, bro. Do you guys know this shit? It's been a while for me, man. It's a refresher. I'm gonna refresh. All right, gotta refresh a little bit. You know what I'm saying? Shit. Gotta refresh a little. Let's do the physics, baby.
Hi, I'm Brian Mullen, and this is Balls Out Physics, Episode 2, The Gravitational Constant. Before I begin, I really want to thank everybody who commented on the first episode. The positive feedback was fantastic. I had no idea the video would be so well received. Thank you all for taking the time to watch it and really think about it. And even in some of the negative comments, there were some very good questions asked. And I would definitely like to revisit the plane problem after a few episodes. But there's some topics I'd like to cover first because I think it'll better explain the plane problem as we go along. And so the other thing I want to say is that I'm not claiming to be right about all this. You know, when I first discovered flat Earth theory, I thought I could debunk it right away.
Not claiming to be right. Definitely
The
not.
problem was I couldn't. I realized that there were some very good points being brought up by the flat Earth community, and that's why I
Very good points.
started this series, because I'm really asking for help here.
The water on a spinning ball.
I can't explain
Brian needs help, man.
these things, and
He ain't getting it, man. Here we are 10 years later. He still ain't getting no help,
you know,
bro.
I've got a pretty strong physics background. I took 2 physics courses in high school and then a bunch in college to get my degree, and maybe I'm missing something, maybe I'm not. But one of my favorite sayings in the engineering world is, you learn 10 times more from your mistakes than you do from your success. This is what we always tell rookie engineers. This is what they told me. Don't worry about making mistakes. Don't worry about being wrong. Because when you are wrong or you do make a mistake, you want to find out why. And on the way to finding out why, you learn a ton. So never be afraid to be wrong.
That's really good advice, man. I mean, what's up, Doc? What's up, Doctor? FE Nation.
Because you can learn from it. And no one on this earth who has ever lived on this earth has ever been right all the time. All the time. It just,
Nobody's been right all the time. Ding dong.
it's never going to happen, and it's never happened. So accept it. Learn from it. So anyway, this episode is mainly about gravity, but it's about the gravitational constant in the gravity equation. However, to get there, we need to start with some basic physics. And so I've set up a problem here with the Earth, represented by this blue ball, and me, or
Did he say blue ball? I think he did. I think it might have been a subconscious thing. Right? I think he said blue ball.
with the Earth, represented by this blue ball.
He did say blue ball. Okay. Is it blue? Maybe it's blue. It could be some shitty.
And me, or any other
He might have used a blue marker. I don't know. It's hard to see, man. This is some old fucking tech here, bro.
with the Earth, represented by this blue ball, and me, or any other man or woman, standing on the Earth, and how we determine the weight of that person, okay? Or the force of gravity acting on that person. Weight and the force of gravity are actually the same, or at least that's the accepted belief in physics. You know, weight is actually caused by the force of gravity.
W equals FG. W equals F off. Okay. Can I change it to off? F off?
Of the Earth pulling down on the object, in this case, the person. And so the bread and butter physics equation up here one of the first equations you learn in Physics 1 is force is equal to mass times acceleration. This is what Newton based all of his three laws of motion on. And since his boy Copernicus, 150 years prior,
His boy Copernicus, his boy Newton's bitch. Wait, no. It would have been Copernicus's bitch is Newton, right? I got to get that right, man, right? Whose bitch is who, you know what I'm saying? WXFU, exactly, Jeeps. Right, exactly.
three laws of motion on. And
Or
since his
FO.
boy
It could be FO or FU. It could be either one, you know. Anyway, trying to make this fucking physics fun. Fuck. Trying to make physics fun. Fuck. Good luck.
based all of his three laws of motion on. And since his boy Copernicus, 150 years prior, had come up with the solar system, he knew that he needed to come up with an equation that would not only work on Earth, but would work throughout the universe. Okay? And so what this equation says is that the force acting on an object is equal to the mass of that object multiplied by the acceleration that the object is experiencing. Okay?
You guys are all tracking, I see. You guys got this?
And mass
Yeah, the weight in force gravity terms. Yeah, exactly.
is defined as the amount of matter in an object. And in Physics 1, they hammer into your head that mass is the same throughout the universe. Only weight changes because the gravity on each planet can change. You know, the gravity on the moon is less than it is on Earth. It's supposed to be about 1/6 of what it is on Earth. And so I was taking physics, and I had just taken chemistry, or I was taking it at the same time, I can't remember. But I immediately thought about the fact in the lab we were weighing things in terms of grams. And in the metric system, grams and kilograms are actually units of mass. But to determine mass, we actually weigh it, or weigh an object, and we say this is how mass.
You got to weigh it. There's no measurable downward acceleration happening. It's only observable. There's zero force acting on the mass in free fall. Exactly, doctor.
Of it is. And so I thought to myself, well, if that's the case, if I took that same scale up to the moon, it would definitely give me a different reading because the force of gravity is less, and that's what's pulling the scale down, right? So how can that be? How can mass be the same throughout the universe? Does that mean we would have to calibrate our scales to work on the moon so that they show the same mass that we get on the Earth? Or do we use a conversion factor instead? Or how does that work? Does that mean that just all mass in the universe is actually...
One of the sad parts of Brian Mullins doing these presentations is that his channel he had to delete his fucking channel. I think he'll come back one day, man. Brian will be back one day, man. Once he's in a better place, he'll come back. I really believe that, man. You guys think he'll come back? Yeah, he'll be back. Yeah, and thank you, Brian. Fuck, please come back, bro.
How does that work? Does that mean that just all mass in the universe is actually defined on Earth? I don't know. I never really got that, but at the time...
By the way, man, the guy that turned you in, that made you delete your channel, he passed away. Rest in peace, George. Rest in peace, brother.
The universe is actually defined on Earth?
Yeah, well, he got called out by some globetard named George Cockafucking remember his last name. It had something to do with cock. Yeah, he admitted that he called the engineering board on Brian, said this guy's putting out some false information, bro, or something like that, man. Yeah, the fucking rat. Some globe fucking tarred rat, man.
Does that we use it on the moon so that they show the same mass that we get on the Earth? Or do we use a conversion factor instead? Or how does that work? Does that mean that just all mass in the universe is actually defined on Earth? I don't know. I I never really got that, but at the time I had been in school for a long time. I was 18 years old and I was ready to get out and go make some money, so I didn't really ask too many questions. However, I always questioned that and I always thought about it, and I've talked about this with some other people, and there are a lot of people that say, yeah, that doesn't really make a whole lot of sense, but it's accepted in the physics world. So anyway, that's mass, okay? The mass of an object, the amount of matter in an object. The acceleration,
Yeah, Jeeps. You know he's going, oh shit, I was wrong. I had a friend, a great friend, longtime friend, decades friend. He had a heart attack, died, went up, while he was dead. He says he went up and he could see the whole earth and it was flat. And the second he came back from death, like the minute he came back from death, they got him back. He goes, dude, give me where the fuck is my iPad? And he started searching Flat Earth out, man. Yeah, the true story, I can get him on the phone if anybody wants to question me on that story, man. But it's a true story, bro. Yeah. This whiteboard, man. Come on. I'm trying to make it fun anyway. Whiteboards can be fun.
so anyway, that's mass. Okay? The mass of an object, the amount of matter in an object. The acceleration is defined as any change in velocity. Okay? So velocity can be measured in miles per hour, as I did show in the first problem, or kilometers per hour, kilometers.
All right. I brought him on years ago to a live stream years ago, man. But I'll do it again far out. For you, man, I'll fucking do it for sure. I'll get him, man. One of these nights, man, I'll set it up. I'll give him a call. He can tell you the story way better than I can, man. And what's up, Ersh? What's up, baby?
Second meters per second.
But yeah, that's we'll get to it. We'll get to my buddy Al. Big Al, man, ice cream pal, man.
Velocity. Okay. So velocity can be measured in miles per hour, as I did show in the first problem, or kilometers per hour, kilometers per second, meters per second, whatever. That's the rate of velocity. However, acceleration is defined as any change in velocity. So in this example, if I'm standing right here on this earth, okay,
Guess what? Brian is standing on Earth right now. Did you guys know that? In the video. Wait, we're all standing on Earth right now. Fuck. Okay, we're all standing on Earth. Let's go. Here, what do we got?
In this example, if I'm standing right here on this earth, okay, I have a velocity. I'm moving with the earth. As you remember in the first problem, we said I'm in Central Florida. My velocity is probably around 900 miles per hour, maybe a little less, somewhere between 850 and 900 miles per hour. Okay, but since the earth, I'm supposed to be standing on an earth that is rotating, this direction of that velocity is constantly changing. Okay, so when I get over here, this is exaggerated obviously, but now my velocity is pointing this way.
Oh shit. You're gonna fall off the earth, dude. You better grab onto a rope or something, because you're gonna go sliding down the hill, ding dong.
So, even though I'm standing at rest, because of this theory, I'm constantly accelerating, because the direction of my velocity is constantly changing.
That's right, Mac. We're all fucking standing on the earth. Oh shit. Ain't that something? Ding dong. Fuck.
I'm constantly accelerating, because the direction of my velocity is constantly changing. And this will be better explained in the next episode when we talk about centrifugal force. So anyway, since weight and mass are different, weight is actually considered to be a force. This force of gravity, we have weight over here and weight here. Weight is equal to the force of gravity.
You guys tracking? You guys got this. I'm a bunch of professionals up in here tonight. Damn.
Pulling me down. Okay? So this equation can be rewritten F equals ma can be written as weight is equal to mass times little g here. And little g is considered the acceleration due to gravity, or the acceleration at which things fall towards Earth. Now, I posted a link in the description.
Fucking G. Little G. Little G. That guy's a little bitch. Little bitch G.
To
What about... There's a big G, though. You got little G and big... Fuck.
trailer for the BBC
It sounds like a bunch of rappers to me, man. Little G, big G. You know what I'm saying? Fucking sounds like gangster rapper shit, man, or something.
series, episode 4, Human Universe, in which Brian Cox for towards Earth. Now, I posted a link in the description to a trailer for the BBC series, episode 4, Human Universe, in which Professor Brian Cox from the UK.
Brian Cox. Brian Cox.
Travels to the Glenn Research Center in Cleveland, Ohio, to do an experiment with NASA's vacuum chamber. And in the experiment, they drop a clump of feathers and a bowling ball. And the first time they drop it when there's air in the chamber, you know, the bowling ball obviously falls a lot faster than the clump of feathers. But when they remove all of the air from the vacuum chamber, both the feathers and the bowling ball fall at exactly the same rate.
You guys have all seen that video, right? I mean...
So what this little g says is that all objects accelerate towards Earth at the same rate unless there is some type of fluid preventing them from falling at that rate. And so the more dense something is, the faster it'll fall through the air. The less dense, the slower. It's just like in water. You know, something heavier or more dense, more massive will sink faster than something that's less massive or less dense. And if the density is actually less than water, it'll float. And the same with our air. That's how hot air balloons work.
There you go. Right? Boy, you guys are burning up the chat, man. I can't keep up, man. So excuse me if I'm not totally tracking you guys, but you guys are killing it. Thank you.
Or, you know, blimps with helium inside them,
Shit.
balloons. That's why they float, because their density is less than that of air. But when you get rid of air or any fluid, everything falls at the same rate. And that's a really great episode. I highly recommend you watch it. It's very interesting to see.
Yeah, it turns out they might have fabricated that a little bit from what I've heard. That particular one with Brian Cox. Yeah, they might have fucking cheated that a little bit. I don't know, it's fuck. It's still Speculation Sunday here for another hour. I can speculate. Give me a break.
Episode, I highly recommend you watch it. It's very interesting to see. Okay, so that's weight. Okay.
What's up, Bear? You fucking Mongo. Fuck.
And weight or force in the metric system.
Fuck. Dude, we're in physics here, bro. We're doing deep dive physics. Man, you're late to the party, Bear. But you'll get this quick, man, because you deal with coffee. And coffee has gravity. There's gravity in coffee, isn't there? I believe there is gravity in coffee. I know there's gravity in alcohol. So you'll get it. This is the gravitational constant we're dealing with here, okay? And it's a big subject. It's deep, man. You gotta know your physics, man. You gotta know it. If you're gonna be a flat earther, man, you gotta know your physics, bro. Let's go.
It's very interesting to see. Okay, so that's weight, okay? And weight or force in the metric system is measured in newtons, okay? So 1 newton, obviously they gave credit to the guy that came up with this. 1 newton is equal to 1 kilogram times acceleration due to gravity, or rate at which things accelerate towards Earth, which is 9.81 meters a second square. So
You guys know about the 9.81 meters per second squared, or the other English way of saying it is 32 feet per second per second. Have you guys ever heard that term? 32 feet per second per second. Yep. No sugar ever. No gravity. Fuck. That's what it's measuring. When you measure alcohol, you're measuring the sugars, right? That's correct. I did that a couple times. Yeah. All right. We got this. We got this. Okay.
Acceleration due to gravity, or rate at which things accelerate towards Earth, which is 9.81 meters a second squared. So 1 squared. So 1 Newton is equal to 9.81 kilograms times meters per second squared. Okay, remember that. Newton is really equal to units of kilograms times meters per second squared.
Per second squared. Got it. Got it.
Is equal to 9.81. Okay.
You guys tracking? You guys are tracking. Fucking 32 feet per second per second. Yeah.
So I weigh about 160.
Yeah. You got to hit the gradual, bro. Hey, man, don't hit too much gradual. Granular. Don't. All right, we'll be all right, man. I'll be fine. You guys, don't worry about me, man. You guys are great. Oh, shit. He erased a bunch of shit. Damn it.
I weigh about 160 pounds. And in the English system, I could just say that's pounds mass. Or actually, I can say that's pounds force. But in the English system, we don't actually differentiate between, with two different units between mass and weight. There is a unit called a slug that's used for mass, but nobody uses it. Or there is mass, but nobody uses. So if I say my weight is 160 pounds force, I can convert that to mass in the metric system, which is about 72.6 kilograms. So my weight in the metric system would be 72.6 kilograms times 9.81 meters per second squared equals roughly 712 newtons. Okay? That's my weight in metric units. So,
oh shit.
Over here, we have the equation due to gravity. Okay. And that says that the force of gravity is equal to the gravitational constant times the mass of one object, in this case me, this is represented by a little m, times the mass of another object, which would be the Earth, divided by the distance between them squared, which in this case would be the radius of the Earth. Now you should actually add the distance to my center of mass from the...
There's that little bitchy R. That little fucking R, little bitch. The little fucking R. You fucking... Where'd you get your R, ding-dongs? Where the fuck did you get the R? That's been a question for a long time, man. Nobody's ever actually answered it, but, carry on.
Divided by the distance between them squared, which in this case would be the radius of the Earth. Now you should actually add the distance to my center of mass.
You got it from some dude 2,500 years ago? Some guy 2,500 fucking years ago came up with the R. Oh, okay. That's cool. Good for him, bro.
Mass from...
How did he do that? Oh, he had some stuff, some tree branches and shadows and things. He had he had a bunch of really cool, angled things, angled dangles.
You should actually add the distance to my center of mass from the Earth's surface, but it's so insignificant that it doesn't really matter. Okay? And the gravitational constant, which I should have written down here, is equal to 6.67.
No, 6.67?
408 times 10 to the negative 11.
What? I'm fucking lost. Oh, shit.
Meters cubed over kilograms times seconds squared. Okay?
How the fuck you get all those fucking numbers, bro? Where'd you get all these numbers, man? Fuck.
Grams times seconds squared. Okay? So if you plug the mass of Earth, which I have written here, which is 5.9726 times 10 to the 24th kilograms.
That's a heavy Earth, bro. I don't even mean. Whoa. That's a massive Earth, bro. It's massive.
Really big number. My mass, 72.6 kilograms. And the gravitational constant and the radius of Earth, which is 6,371,000 meters.
Got your R. R means R. Radius. R. R. You guys are pirates? Any pirates out there? R. R. That's why the pirates fucking knew. That's why they went R. I'm just saying, man. I think that's why the pirates used R. I got the R.
You will get 712 newtons, roughly. Pretty close. Close enough to say it's the same. To say that to accept the fact that, well,
accept the fact, and he looks back at the camera and goes, to accept the facts, okay.
To accept the fact that, well,
You have to accept that radius, Mongos. Once you accept that radius, yeah, you gotta own it, and you gotta fucking own it, bro. Let's own that shit.
accept the fact that, well,
That was clever, Brian. Thank you.
assumed fact that gravity is causing this weight, and that's why I have weight is equal to the force of gravity on here. Okay, this is what is taught in physics.
That's right. It's what's fucking taught in physics, man. Let's go. R, where's the rum? R. Where's the radius? R. R. Where's the radius? Give me the radius, R.
That this force of gravity actually creates my weight, but there's just two different ways we can calculate it. Okay. But Newton
Fucking Newton. Fucking Newton.
came up with this
What the fuck is up, Chill?
before he came up with the equation for gravity. And in fact, Newton only proposed the equation. He didn't actually finish it. He said, from looking at
Nah, Einstein finished it. Everybody knows that. I mean,
the solar system model and watching things in the sky that he thought or he assumed were orbiting Earth.
what's up, Chillster? Dude Lux, bro.
Based on Copernicus' work, that the force of gravity was proportional to the mass of one object times the mass of another object divided by the distance between them squared. Okay? He said they're proportional, they're not equal. So what this means is, if either one of these masses go up or both of them go up, the force of gravity also goes up. But as the distance between them increases, the force of gravity goes down. And as you can see, this is square, so distance plays a big part here.
Oh, distance squared on the radius. Right? Is that where he's going? Fuck. Did I miss it? Hold on, let me back it up. Fuck. Hold on. Shit.
Go up, or both of them go up, the force of gravity also goes up. But as the distance between them increases, the force of gravity goes down. And as you can see, this is square, so this.
So yeah, I get that. I'm tracking now. So like, if I got a big ball and I move it away from the other big ball, the two balls are not. They're gonna have less energy between the balls. Is that what? I think that's it. Something like that. Fucking these cocks love their balls, man. They just love it.
Plays.
I think the reason they all came up with this globe thing is because they love their balls. They just like, I love my balls, and I'm gonna just make the whole world love balls. Let's go, balls. It has to be a ball every time. I mean, there are just a bunch of balls out there, and I got balls here, and there's balls there, and we live on a ball, and everything's balls. Balls, 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 balls. That's what's going on, man. You know what I'm fucking saying? You got two balls, and then they're clanking together, and then the balls don't clank together. That's how cock these ding-dongs are, man. Fuck. Right? I don't know. I'm speculating. It's still speculation Sunday for me for 45 more minutes. But, you know, I got to scratch my nuts. Hold on. Wait, let's make the whole place like my nuts. It's perfect. Balls are balls. Yeah,
Gravity goes down. As you,
I'm being funny, but I really think that's how these ding dongs fucking think, man. These cucks, man. They're like, let's just make everything balls, because, you know.
can see this square. It's a distance.
They're
place.
weirdos. Those fuckers are weirdos, man. That's all there is to it, man. They're weirdos.
A big part here.
You got bouncing balls left and right. Yeah, exactly. 100% Effie. Yeah, we're bouncing our fucking balls all over the world, man. We're going to make the whole universe bounce some balls. Fuck, let's do it. You fucking... Okay, how do we make it work? I don't know. Bring in some smart math fucking guys, and then, yeah.
So, he eventually
Fucking balls.
proposed
Fucking
that he
balls
needed
out
this-
physics, man.
this big G up here, this gravitational constant. And
I don't know if I don't know if Brian knew how fucking straight on he was, how good he was. Maybe he didn't. Maybe he'll come back, but I hope he comes back. But yeah, he was right calling it balls out physics, man, because it's literally what we're dealing with, man. Is balls out fucking physics, man. The ball physics is so crazy stupid, bro. It's ridiculous.
he eventually
It's ridiculous.
proposed that he needed this big G up here, this gravitational constant. And he didn't know how to determine that, but he did know that the units would be what we have right here, meters cubed over kilograms times second. Now, he might not have been using the metric system then. I haven't actually looked into that, but he would have been using something similar. So I'm just going to assume that he used metric units, because if you combine the units in this proportion right here, you would get, assuming the masses are measured in kilograms, you would get kilograms squared over meters squared.
There you go.
And if you multiply that times this factor down here, you will end up with kilograms times meters a second squared, which is equal to a Newton, or a unit of force.
Gotta have a Newton. Gotta have a Newton. Good night, Trace.
Okay, just like I showed in the
Be
original
good. Be good, girl.
equation, the original bread and butter equation over here. So, that said, he theorized that there was this gravitational constant, but he didn't actually figure it out before he died.
I love it when the Globers come in and go, well, everybody knows this, man. I mean, like, F equals MA, fucker. You fucking dumbass flat earthers. Yeah. Come on, man. Everybody know. Yeah. Brian learned the same things in his physics classes, and, you know, he's just sharing it with us. Just sharing it, bro. This is what you learn, ding-dongs. This is what you learn, fuckers. Let's go.
There was this gravitational constant, but he didn't actually figure it out before he died. And it wasn't until a little over 100 years later, about 120, 130 years later, that a man named Henry Cavendish came along.
I call him Cavendish. Fucking Cavendish, man, with his balls. I got balls going lateral. They weren't even going up and down. They were going lateral. That's what my problem with Cavendish, bro. Like, I just came up with this little balance beam thing, man. Like, hey, it's lateral, man. You know, gravity works laterally and it works up and down, apparently. Fuck. It works. Gravity's everywhere. Left, right, up, down. Yeah, we can. Yeah, Cavendish. There you go, Bear. Fucking Cavendish. That's a great name. I'm going to use it. I'm stealing that shit, man. Fuck off.
Henry Cavendish was very wealthy, and he did a
First of all, he's very wealthy. And the other thing I learned about Cavendish is he never actually could talk to you face to face. He had to be like behind a curtain or something. Kind of like the Wizard of Oz kind of thing, man. Pay no attention to the man behind the curtain. Check it out, man. Don't believe me, man. Cavendish was an absolute fucking total tweaker, dude. Yeah. It was weird, man. The fucking Cavendish is a total tweaker, bro. 100%.
Cavendish came along. Henry Cavendish was very wealthy, and he did a lot of things. Apparently, I've listened to some very respected physics teachers praise his work, and studied some of his work, but mostly.
I mean, the whole, London Science of Technology Museum, they just love the Cavendish. They just love him. He's great. He's our hero. We praise
his work.
Fucking Mongos.
Studied some of his work, but mostly what I was interested in was how he determined this gravitational constant. Okay. Cavendish apparently had a lot of property, a lot of money, and he set up an experiment where, get rid of all this.
He had a London cottage is very, very, very rich.
Now let's go back to where we just have these two equations. They haven't figured out the big G yet. They do know the radius of Earth, though, because they knew this.
Oh, fuck yeah, they knew the radius because of some cuck 2,500 years ago. The fucker knew the radius.
The big G yet. They do know the radius of Earth, though, because they knew the circumference. So they knew.
Dude, there you go. They knew it.
The radius of Earth, but they didn't know big G, and they didn't know the mass of Earth. Okay, so.
Oh, they didn't know the mass. They knew the radius, but they didn't know the mass.
Going back to Cavendish in 1798, Cavendish built this box.
He built
wooden box on his property.
Fucking Cavendish built a fucking box.
Something like this.
That looks like a box. Okay, Cavendish. What else you got there, Cavendish?
Okay, and in this box, there was a pulley with a rope leading outside the box, something like that, a little handle on it. And what hung from it was this thing called a torsion rod.
Torsion rod?
Something like this.
Yeah. Torsion. It sounds torturous. Torsion. I don't know. I could be wrong.
And on the ends of the rod were these large lead balls.
There's the balls again. You got to have the balls. The balls in the box. The balls in the box, Jeeps. Come on, Dex. Everybody's got balls in the box. I will not go there. I'm not going there, bro. I'm not going to do it. Not going to happen.
On the inside were these smaller lead balls. Something like this.
It's smaller balls. Hold on. You got big balls and small balls. Ugh.
Pulley right here.
Dude, I can't make this shit up. This is hilarious.
And he used lead because it's very massive, it's very dense. And he, apparently, according to the history, he knew that he had to get away from the box because his gravity, his mass, would affect the
sideways. Gravity works sideways too? What? Okay.
Experiment. Assuming that this is correct, that the force of gravity is you know, there's a force of gravity between any two masses, not just the Earth and us. All masses have a force of gravity on each other, or create a force of gravity on all other masses based on this equation and the proportion that Newton came up with. So he somehow set up some telescopes that went back to his house.
Right.
You know, keep his
Telescopes.
house off
Telescope. You gotta have a
the
telescope.
board. Just assume his house is down here somewhere. So he could observe this experiment, and somehow he calculated big G from this. Okay. Well, when I started researching this, I said, okay, well, let's see some examples of a modern day torsion rod experiment that somebody's built that shows how this works. Well, I couldn't really find one. I actually had a lot of trouble finding.
He's a peeping Tom. Exactly. Bear, the fucker's a peeping Tom. In the keyhole. Through the keyhole. Yep.
Anymore. Actually, one of the physics professors that was praising him had a little model that he held up, and was joking that his TA couldn't get it to work and got frustrated with it and gave up.
Yeah, couldn't get it to work, bro.
And I'm thinking to myself, over 200 years later, we don't have
200 years later, we got super technology, 3D printers, fucking laser cut, fucking precise, fucking to the fucking tits engineering. And we can't do it now? What?
models of this, or repeats of this experiment all over the place to determine big G. It didn't make much sense to me.
Fucking peeping Tom. That's what he was doing. I love you, Bear. Love you, baby. He's peeping Tom. Fucking mongos.
So I said, okay, well, going back through the history, let's assume that he did this somehow.
He was looking at balls through his telescope, man. What kind of balls? I don't know, man. Probably some little balls and some big balls, together. working together. The big balls and the little balls working together. There you go.
Really smart guy, and we just haven't been able.
Yeah, really, he's kind of a real creepy guy, actually. Yeah. Looking through his telescope. Exactly. I mean, I'm just pointing out the obvious shit here, man. I'm speculating, but, pointing out the balls.
History. Let's assume that he did this somehow. He's a really smart guy, and we just haven't been able to get it to work again. Okay?
Yeah. Fucking ding dong.
So, Cavendish determined big G through that torsion rod experiment.
Cavendish came up with the big balls, the big G.
Okay?
All right.
He calculated it to be the value that we're still using, which is 6.67.
Couldn't be 6.66, man. I mean, that would have been too much a giveaway. I mean, it had to be 6.67, man, right?
408 times 10 to the negative 11 meters cubed over kilograms times seconds squared. Okay? He determined that from that experiment. Let's assume that's this.
Fucking A, man. Got a big number out of that fucking balls experiment. It's a balls experiment. Gotcha. Okay.
That's correct. So now he must have been really excited
I'm tracking. Am I tracking? I think I'm tracking, right?
because he knows what this big G is. He knows what his mass is, or any other mass of an object on Earth. He knows what the radius of Earth is. So
You gotta know the R. You gotta know the radius, fuckers. You gotta have that first, man.
he can set these two equations equal to each other. He knows that weight and the force of gravity
Fucking Bear. You're hilarious.
are equal. So what he did was, you can look this up, this is exactly how this was done. Weight, which is equal to mass times G, or the mass of the man or whatever object he's using, in my case I'm going to say me, is equal to big G times the mass of the man times the mass of Earth divided by
Got to have the mass of Earth and the radius in order to do these calculations. You guys know that, right?
the radius of Earth squared. Now immediately you can cancel the mass of the object or me out because they're in the numerator on both sides. This is really mg over 1. Okay? And now, let's come up here. You can solve for the mass of Earth. You can multiply the radius squared times both sides, and that comes over here. Cancels on this side, and then you can divide by big G. So you get me, and this is basic algebra here, is equal to little g, the acceleration due to gravity, or the rate at which things accelerate towards Earth.
I think this is where George called the engineering board on Brian. I think this is where he called him out. I do think I remember something like that, right?
Times the radius of Earth
What the fuck?
squared divided by big G. And that is how the mass of Earth is calculated. That is the mass that NASA had on their fact sheet, where I got all this information about the Earth's radius and the mass of Earth and everything.
Some basic math, fellas. Let's go. We got this, man. It's a basic fucking math. And 10 years later, man. That's why I'm playing it. And kind of revisit, kind of make it laugh and have some fun with it, because it was so right on then, and it's still right on now, man. Brian fucking crushed it, man. He fucking crushed it, bro.
For this problem. Okay? So I looked at this and I said, okay, that makes sense, but I still had the question in my mind saying, wait a second though, why can't we do this torsion rod experiment now? There's some, I looked into this more, and right now there's debate going on about what this big G actually is. Some people are arguing and saying it's different. And they're doing experiments on an atomic and a subatomic level where they're looking at particles with very powerful microscopes and observing how they're attracted to each other, which they say is because of gravity. Now, I can't go buy an electron microscope and do those experiments myself to check it because I don't have that much money. And I don't want to try to build a torsion rod experiment because from everything I read, it sounds like it's not going to work. So I'm also going to spend a lot of money on that. So I'm really questioning, this big G. How did they come up with that? But then I started to look at this algebraic expression that was written. Get rid of big G again.
I started to look at it a little bit deeper into how the fuck they came up with this shit. And here we are. We're checking it out, man. We're
Get rid of big G again.
How the fuck did they come up with this
Well,
stuff?
what if they were so sure about this equation due to gravity, or this equation of gravity, that they were having trouble coming up with G, that they did something else to determine it. What if they did?
What if they cheated? Oh, interesting proposition. It is Speculation Sunday for me for another 29 minutes. Let's go. What did they fucking come up with, these fucks?
This. Or Cavendish did this. What if he said G is equal to the acceleration due to gravity, as he would have called it, times the radius of Earth squared, times the mass, or divided by the mass of Earth. Of course, he doesn't have the mass of Earth, right? Well, he does have the radius of Earth. And at that time, they definitely knew how to calculate the volume of a sphere. The volume of a sphere is equal to 4/3 times pi times the radius squared, or cubed actually. In this case, it's the radius of Earth. And so since they know the total volume of the Earth, they know that if they could figure out the average density of Earth, they could multiply that by this volume and get mass. You know, if you know, at the time they would have known the density of water and the density of sand, the density of ground rock, the density of iron, the density of gold, the density of silver, the density of all these things were already determined. And to determine the density of something, it's really just the mass per unit volume. For example, we'll call them rho. Call rho density. Rho water is equal to 1,000 kilograms per meter cubed. What that says is in 1 cubic meter, if you have you have something that holds a cubic meter of water, it weighs 1,000 kilograms. If you have something that holds 2 cubic meters of water, you say the density of water 1,000 kilograms times 2 cubic meters. You see the cubic meters would cancel. You get 2,000 kilograms is how much it would weigh. Okay. So you definitely know the density of water back then. You definitely know the density of, let's say sand and soils, which is roughly 1,200 to 1,600 kilograms per meter cubic. And they definitely knew the density of iron. I mean, they were building things out of iron a long time before that. We'll call that rho I.
Damn right you like his measuring tape. I mean, isn't that what we use? Our arms? Come on, Jimmy.
And that is equal to 7,780 kilograms per meter cubed. Now, whether they were using metric units again, I don't know, but they would have had their units that could be converted to the units I'm using now. The metric units I'm using now.
Well, how the fuck does this scale work in space, bro? I mean, that's a good question there, Dax. Yeah. My scales are in space, bro. How does that work?
Now,
oh, shit. We got a problem here.
based on
I think it's called the 3-body problem, actually. But never mind.
the volume of Earth, let's call that VE, the volume of Earth is actually 1.083 times 10 to the 21 meters cubed, okay? If you use NASA's fact sheet with their mass of Earth, which is 5.9726 times 10 to the 24th kilograms, and you divide that by the volume of Earth, you will get an average density of Earth, I'm going to call that rho E over here, of 5,515 kilograms per meter cubed. Okay? So,
Nice.
looking at this,
Nice.
just looking at water and soil, water is, the average density of Earth is over 5 times greater than the density of water. And water is actually pretty dense. If you've ever done a belly flop into a pool, you've experienced how dense it is. But, the average density of Earth is 5 times that of water. It's also a lot greater than soil and sand, which is really ground rock. But then you look at the density of iron and notice that actually the density of Earth is pretty close to the density.
Yeah, it's like being back in school, but it's, I got 10 years under my belt of listening to this shit, man. Listening to people debate this shit. And it's like, okay, let's go back to where the debate started. The debate started. Here it is, man. This is where it actually started. This is where the debate started. And this is what caused all these people to freak out, man, and go, well, you flat earthers don't understand. You guys don't get math. You can fuck off, man. Yeah, we get it, bro. No. We get it. And that's where I'm at, man. Let's go and review this shit. Let's go.
Then you look at the density of iron and notice that actually the density of Earth is pretty close to the density of iron based on everything that was calculated, the mass that came from this relationship up here. So I started thinking, this is pretty high, and that's exactly why we theorize that the Earth has an iron core, because this is the average density of all the stuff in Earth, all of the elements, everything on the periodic table that we know. Now, at the time, they didn't know all the elements on the periodic table, but they knew a lot of things. So what I'm saying here is, if you follow where I'm going with this, how do we know they didn't guess, or that Cavendish didn't guess this mass of Earth? And then
Cavendish didn't. He fucking guessed. Cavendish guessed. I guarantee it, man. With a big G. I guarantee it. With a big G.
Yes.
Let's go.
Or that Cavendish didn't guess this mass of Earth. And then just use it to solve for G. And then do the opposite and say that he did this. That he solved for the mass of Earth using that value of G. It's the same thing, just based on the algebra. And then if you plug both of those values into this equation up here and use the mass of any object, whether it's a man, a horse, a carriage, anything, and use the radius of Earth, you're going to get a force that's equal to the weight you get for that same object if you just multiply the mass of that object's time the acceleration due to gravity, or the rate at which the acceleration at which things fall towards Earth. Seem far-fetched? I don't know,
No, it's not that far-fetched, bro.
The fact that we can't really get this experiment to work, this torsion rod experiment to work, is perplexing. Very perplexing. We have to trust that they didn't do this. But what if they did? Our entire solar system model stems from this. Assuming that this is correct. Assuming that this big G, this gravitational constant, is correct. So, I don't know. I don't know what to think. But one thing I do know, based on my research, another thing I found out based on my research, is that Cavendish and Newton were both Freemasons. It's a very big club, and back then, the average person couldn't even write their own name. So people slowly were introduced to the sciences. More and more people were introduced to the sciences over the years, and it wasn't just the wealthy people over the years. And I know there's a symbol out there that a lot of people have been trying to figure out. It looks something like this.
There's your big G,
Have you seen one
Mongos.
of these before? I found one on Freemason Lodge.
There's your
Kinda
big
ominous symbol.
G.
First time I saw it, I was like, what was that? What is that? It's very strange. Compass and a protractor. The big G in the center of it. What does that stand for?
I wonder.
I don't know. Could just be a coincidence. Some people think it means geometry. Some people think it means God. I don't know. Some people even think it means Gnosticism. I've done a little research on this. Who knows? But maybe that's just a coincidence. I'm just asking questions. But in the next episode, we'll look at the relationship between this equation and the centripetal force equation and how it was used to develop our solar system. Till next time.
Oh, shit, Mongos. There you go, man. There you go. Thanks for hanging out, man. Gravity, bro. Guess who came up with it? Cavendish. Cuckendish, man. Cuckendish. I'm going to call him. Fuck that guy, man.
Thank you very much.
Yeah. Cuckendish.
And babies in a run around, hanging with a crowd. Put your business in the street and talk it out loud. You're saying about this and that. and how much you don't spend. I swear you must believe it's all that it's in. Hey, boy, you better get back on the town. Face the sad truth to the dirty low down.
I wonder, 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 wonder. I wonder, 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 wonder.
Nothing you can handle, nothing you can got. Put your business on the table and drive it out the lot. Put on that old love light, turn the Navy to the years. The same old scuba game got me through this mess. Hey boy, better go back to town. Face the sad truth of the dirty hood down.
I wonder, 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 wonder.
Put those ideas in your head.
I wonder, wonder, wonder,
Come back there, little sir. It's a low, 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 low down. You ain't gotta be so bad, gotta be so cruel. All you don't resist, the show is getting dull. Gotta have a Jones for this, gotta have a Jones for that. It's funny to know with them Jones, boy, it just ain't where it's at. Hey boy, better get back on the town. Face the sad truth of the dirty hood down. I wonder, 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 wonder. With those ideas in your head. I wonder, wonder, wonder. Jonas Brown on guitar, Sebastian Rodriguez on keys. Give it up for Sebastian. Here's Kevin Zanitas on trumpet. Get up for Kevin. Here's Bobby Master on saxophone. Get up for Bobby. Got Luke Foot on bass. And Sean Byington on drums.
Isn't she lovely? Isn't she wonderful? Isn't she precious? Less than 1 minute old. I never thought love would be making one as lovely as she. It's so very lovely. Made for love.
Yeah, baby. Yeah, baby. Let's go. Let's go. Bass is low? Oh, really? All right. Crank it up. Crank up the bass. All right. This is it. I got to go to bed.
He came from somewhere back in a long ago. The sentimental footballs, he trying hard to recreate what are yet to be created. But once in her life, she musters a smile for his nostalgia. What you wanted to say, oh little
Did you guys get the song? You guys got the song, man. The wise man has the power and to reason away. To reason that you're on a spinning ball, bro. I mean, they can reason that shit. That's because they're the wise men, bro. That's what happens. They're the wise men, and you don't know nothing from nothing. And you'll just go, okay, yeah. It makes, yeah. We're just go with the wise man said. The wise man said, bro. What are you going to do, bro? The wise man said.
Thank you very much. This
Oh,
next one is also watching it.
All right. Una mas. I got to go, man. I got to go to bed. You guys got to go. You get up. Whatever. Yeah. The wise man. Yeah. Fucking wise man. Pay no attention to the man behind the curtain.
Oh, everybody's got a thing, but some don't know how to handle it. Always reaching out in vain, just taking the things not worth having. Don't you worry about a thing. Don't you worry about a thing, mama. 'Cause I'll be standing on the side when you check it out. They say your style of vice or drag, and that you must go other places. But don't you seem too bad when you get fooled by smiling faces. Don't you worry about a thing. Don't you worry about a thing, mama. 'Cause I'll be standing on the side when you check it out. When you get on the trip, and don't you worry about a thing. Don't you worry about a thing. Don't you worry about a thing. And don't you worry about a thing, mama. 'Cause I'll be standing on the side when you check it out. When we get off the ship. Hey, everybody needs a chance. A chance, coming through. But you're the only one to see the chain that you're fighting yourself through. Oh, yeah, don't you worry about a thing. Don't you worry about a thing, pretty mama. 'Cause I'll be standing on the side when you check it out. Don't you worry about a thing. Don't you worry about a thing. Don't you worry about a Don't you worry about a thing. Don't you worry about a thing, mama. 'Cause I'll be standing on the side when you check it out.
Check it out. Check it out. Check it out, man. Check it out.
Don't you worry about a thing, Captain Scoob.
Don't you worry about a thing, man. All right. Love you guys. Catch you on the flip side, man. Catch you. We'll do it again. That'd be fun, man. All right. Thanks for physics, man. Love the physics, bro. Cavendish came up with all kinds of R's and G's, and fucking guy's busy, man. Guy's a busy guy, man. All right. Peace out, Scotty. Jax. Far out, man. Far out, man. Dax. Far out, man. All right. Just keeping it real, man. Trying to just, I'm doing my thing, man. Whatever that is. I don't know. I don't know what I'm doing. But let's do it anyway. We'll check it out. Check it out. All right? Thank you, guys. I got to go. Busy day tomorrow, man. Let's go. Cheers. All right.